Okay, so what's happening with the AP tests? Over the weekend, we got this email, which is basically telling us that things are going to be done differently this year for the AP exams. So right now they're planning on, blow this up a bit, a 45-minute online exam at home. Also, the content is going to be cut, so you'll be tested on only 75% of the content, not 100% of the content.
Mm.
So it's everything that they expect most teachers would have covered through March. Which, since we've covered everything, just means there's going to be some topics that you will not be tested on.
Oh.
So I'll be taking a look at that with you in a second. Right now, they're planning on 2 different testing dates. They have not announced what the dates are yet. They're going to tell us on April 3rd, or by April 3rd for every class. But it's going to be different for each subject, just to make sure that you can't overlap.
Mm-hmm.
Um, if for any reason there is a conflict, you'll have a second date in order to make up, but if you miss both, then you're pretty much out of luck. So try to take the early date if you can. Um, you're allowed to take it on a computer, tablet, or smartphone. If you can't submit the work digitally, then you can take a photo of your work and offer that as an option for handwritten work.
So we have to write the equations and explanations in computer?
No, you're allowed to do it by hand and then take a photo of your handwritten work.
Oh, okay. Because it's hard to type in computer.
Right, and if you're taking a timed exam, I don't want you to type.
Yeah.
Do you have a device that has a pen?
What?
Do you have any devices that have a pen, like an iPad or a Surface?
Uh, no, I only have computer.
Okay. Um, what's the resolution of your camera for your phone?
Resolution?
How many pixels?
Um, how can I check it? Wait.
I would check all your devices and try to see which one takes the highest quality picture and just use that.
Mm,
I've been able to read the stuff you've been sending me, so whatever you're doing should be fine.
yeah.
But um, okay, so for Calculus BC, I'll post this to the chat so you can check on it later. But for Calculus BC, they are cutting out Unit 9 and Unit 10 except for these specific bullets. But we still have Units 1 through 8. Left column is included. Right column is excluded. So what that means, if we don't have Unit 9 at all, that means there's nothing on your test for Calculus BC on parametric equations, polar equations, and vector valued functions.
Oh,
So
those are
there's no more polar or parametric equations. For Unit 10, do they have an overview? Yeah, here we go. So they said you need to know 10.2, 10.5, 10.7, 10.8, 10.11. So that's 10.2, you still have geometric series. Integral test. 10.5, harmonic and p-series. 10.7, alternating series. 10.8, ratio test. And 10.11, Taylor polynomial approximations. But that's it. So that means there's no error bound, interval, or radius of convergence. But you still need to be able to find the functions themselves for Taylor series. and be able to do your series convergence or divergence rules.
Mm-hmm.
Okay, I don't think I'm going to change anything as far as prep goes, because you still need to know almost everything except for polar parametrics.
Yeah.
And I still want you to be ready for when you go to college.
Mm-hmm.
But just so you know, when you're studying on your own, and I'll post this document so you can see what actually cut. But some of the content you won't be tested on, so they only have 45 minutes to test you.
Yeah. So like 45 minutes, then you're done up on that AP subject.
Right.
Oh,
So it's going to be a lot faster.
I'm afraid of curves because there is only few questions. So if you miss one, then it's gonna
Right.
cut your point out a lot.
So I do think the change does make it so everything is worth a lot more now. An individual question is going to be worth more for that topic.
Yeah.
They have not posted practice tests for the new format yet, but we should have them by April 3rd.
Oh, they will?
Right.
Mm. That's
So
good.
they're kind of racing now to develop them. But as soon as the final test is finished, then they'll start building the stuff we'll use in order to study for it. Okay, then for mechanics is an easier split. Actually, I think I'll take some time tomorrow and go through mechanics in more depth. So we're already 10 minutes in. But I'll post it here so you can check it later. Left column is included. Right column is excluded. Test is 45 minutes online. You can handwrite and take pictures. Some of the content has been cut.
But I have a question.
Okay.
Is it first time to implement to do online test?
For Calculus BC and for Physics C, yes, but for College Board, no. They have a handful of AP exams that they have done this way. Mostly computer science has always been online, and there's one more. I should have done that. AP capstone courses.
So it is first time to do everything online.
They already have experience testing and scoring students that submitted AP exams from home. Just not specifically for Calculus BC or for mechanics.
Mm.
But that means they already have systems in place in order to accept your work.
Yeah.
And they've also piloted anti-cheating measures and plagiarism software. So once you submit your work, you can expect that all of your work is going to be scanned and tested against everybody else.
Oh.
So if you try to submit work that's not your own and two people submit the same paper, they'll be able to catch that digitally. That's more back-end stuff you don't need to worry about. Okay, so for today, oops, forgot, not quite set.
And I heard they will do some online live about the test, isn't it?
It sounds to me like they're just going to they're going to start a timer once you go to their website, and you're going to have that much time to submit your pictures for your answers.
Okay.
At least for Calculus BC and mechanics. However, if I go back to this AP page, every class has their own notes, so some of your classes might be different.
Mm-hmm.
And then what content's been cut has been different for every course too. Okay, any other questions on calculus before I jump?
Nope.
Okay, so let me make sure I'm on the right page. There we go. Okay, so I'm going to go through our next free response question. We're still escalating up through 2012 this time. So our objectives are to use Riemann sums to estimate integrals and to calculate the average slope and average value of a function based on tabular data. So we're going to run through this as fast as we can. Okay, so I've got temperature of water in a tub that's measured using an increasing twice differentiable function W. W is always increasing. And it's measured in degrees Fahrenheit with T in minutes. At zero, T equals zero, the temperature of the water is 55 degrees. It's heated for 30 minutes beginning at zero, and then values of selected times for the first 20 minutes are given above. Okay, first, we want to use data in the table to estimate W prime at 12. Show how you got your answer, and then tell me what it means with units.
So V prime 12 is W 15 minus W 9 over 15 minus 9.
Okay, so W prime 12 is W 15 minus W 9 over 15 minus 9. Okay, that's good. We just need to substitute.
So 67.7 minus 61.8 over 3.
Over,
Oh, 6.
okay. Okay, so I've got 6.1 over 6, which is 61 over 60. Do you match?
Mm-hmm.
Okay. What are my units and what does it mean?
Units gonna be degrees Fahrenheit per minute.
Okay, and can you give me a sentence just telling me what it means?
So it means the rate of change of temperature.
Okay, the temperature of what?
Changing the temperature of the rate of change. The rate.
No, what does it physically mean? So,
The temperature of the. I thought the rate of change of the temperature at T equals 12 is this.
is it temperature of water? Is it temperature
Oh,
of what?
temperature of water, yeah.
Okay, the temperature of the water is... Okay, you said it's changing, but we can be more specific. Is it increasing or decreasing?
Yeah, increases.
Increasing. Okay, the temperature of the water is increasing at a rate of...
At a rate of 61 over 60.
61 over 60
Fahrenheit per minute.
degrees Fahrenheit.
Mm-hmm.
Per minute. Okay, cool. Any questions on this one?
Nope.
Clean up that A really quick. Okay. Part B. Create an estimate of the integral from 0 to 20 of W prime t, and then using correct units, interpret the meaning. We can actually evaluate. We don't need to estimate.
Mm-hmm.
Okay, so what happens when I integrate from 0 to 20 of W prime t dt?
So 0 to 20, that means the total water.
Okay, so you're gonna give me the meaning first. This is the total water.
Total water, heated.
Okay, heated. Okay, and then I'll need a value, so let's calculate this really quick. What's my integral from 0 to 20 of w prime t dt?
So, oh, that's W20 minus W0.
Okay, w20 is 71, and then w0 is 55. What's 71 minus 55?
16.
Okay, so that's 16 degrees Fahrenheit. The total water heated by 16 degrees Fahrenheit.
From T equals 0 to 20.
Perfect. Okay.
Yeah.
Then from 0 to 20, the average temperature was 1 over 20 times the integral of 0 to 20 wt dt. Use a left Riemann sum with 4 subintervals to approximate the integral of 0 to 20 wt dt divided by 20. And then explain why this will overestimate or underestimate the average temperature.
Oh, so we have to find the random sum, left random sum first. So that's gonna be
With 4 subintervals.
So 55.0, no, 55 times 4.
55 times what?
4.
This is a left Riemann sum. Oh, okay. 55 times 4. Sorry, you're right.
Plus 5 times... Oh, no, I mean 57.1 times 5. Plus 61.8 times 6. Plus 67.9 times 5. Divided by 20.
Okay. So we'll do that really quick. Should be 67.9. Lucky I double checked. It's easy to miss up something when I'm trying to I'm trying to stream and do this at the same time. Okay, so 60.79. What are my units?
Degrees Fahrenheit.
Degrees Fahrenheit. Okay. So this is my average temperature. And then will this overestimate or underestimate the average temperature?
That will underestimate.
So we were increasing and we used a left-hand Riemann sum, so we will underestimate the curve.
Yes.
Okay. Estimate. Underestimates the average temperature as Wt is increasing on the interval. And we used a left-hand Riemann sum. Okay. Then for part D, from 20 to 25, not shown on the table, the function w that models the water temperature has the first derivative given by this. W prime equals 0.4t cosine 0.060. Based on the model, what is the temperature at the time t equals 25? What do I have to do?
So we have to calculate the water pumped in and then water pulled out. So W25 is wait.
So we're measuring temperature.
Oh, W20 plus integration from 20 to 25.
Of
W prime D. W prime T.
perfect. Okay, so that's what's W20?
71.
71 plus we can integrate this. So this is the integral of 0.4 square root t times the cosine of 0.060 in terms of x from 20 to 25. Okay, so I've got 2.043155.
Yep.
So that gives us 73.043. And then what's our units?
Degrees of Fahrenheit.
Degrees Fahrenheit. Perfect. Okay. Check myself really quick. 61 divided by 60. Okay. And all of our answers match.
Yeah.
Okay. Any questions on anything?
Nope.
All right.